here to go over some maintenance procedures on the heat recovery unit that you guys were already introduced to on the roof. That's the first day of training that we had. And also there's an air handling unit that's right next to it. This is AHU 6, I think. I just didn't get to go over the theory section of it. You guys already look around into the unit. If you have any issues with going back up there, we can go back up there, shut the equipment down after we go over this, and if we can go back over whatever practical that if you hear anything in here that you want to go back and take a look at. So, maintenance procedure for those two equipment is kind of similar. It's just that one of them is a heat recovery, the other one is just a regular air handling unit. So, I'm just gonna, whatever I say pretty much goes for both. So the maintaining filters and air cleaning devices, that will be every 3 months, so that's quarterly. And visual inspect or remotely monitor the outdoor air dampers and actuators for proper function. That's also a quarterly thing you got to do every 3 months. Clean and maintain humidifiers to limit fouling and microbial growth. That's also every 3 months. So that's a quarterly thing. Visual inspect and dehumidification coils or cleanliness and microbial growth. Clean when fouling is observed. And that's done every year, annually. Visually inspect drain pans and other adjacent surfaces, subject to wetting for cleanliness and microbial growth, and clean with fouling is observed. That's every 6 months. Visually inspect outdoor air intake louvers, bird screens, mist eliminators, and adjacent areas for cleanliness and integrity. Clean when necessary, and that's required every 6 months. Verify sensors used for dynamic minimum outdoor air control, accuracy, and recalibrate or replace as necessary. And that's done every 6 months. Measure the minimum quantity of outdoor air in the AHUs, except for AHUs under 1,000 pounds. Maintain the floor drains located in plenums or rooms that serve as air plenums to prevent transport of contaminants from the floor drain to the plenum. That's done annually. Please keep clear the space provided for routine maintenance and inspection around ventilation equipment for equipment component accessibility. And that's done annually. Investigate and rectify the visible microbial contamination, and also investigate and rectify the water intrusion or accumulation. That's done annually. Inspect the following parts for damaged dirt and debris. The cabinet. Clean the exterior of the air handler with a mild environmental safe detergent and high pressure water. at 2000 psi. Door, hardware, and gaskets. Inspect the doors, handles, latches, and hinges for proper operation, and the door gaskets for damage, and if they are properly sealed, secure any loose parts. Inspect the panels for damage. If the panels show signs of excessive pressure change, they will appear to bulge inward or outward. Inspect the air hoods and louvers for damage and debris. Remove debris as needed. Bird screens. The bird screens are an integral part of hoods and louvers. Inspect the bird screens for damage and debris. Remove the debris as needed. Inspect the optional mist eliminators in the air hoods for damage, dirt, and debris. Remove the mist eliminators for cleaning as shown later, like in the manual for the unit. They'll tell you how. Clean and replace the outdoor air hoods. Remove mist eliminator or cleanable filter. Clean with eco-friendly solution. Install the new mist eliminator or cleanable filter. Reinstall the clips and legend edges of the hood. Anything so far? Pretty much stuff you guys already know, so. In the fan segment, which goes for the supply return or exhaust, removing the fan. If necessary, remove the fans for cleaning. Clean the fan with detergent or solvent that is environmentally friendly or unsafe. If water pressure is used, do not direct the water stream into the bearing seal. Check the fan housing, wheel, shaft, frame, and bearings. Check the fan base, the vibrational isolators, and optional thrust restraints. Check the flex connectors. Make sure that the fan assembly does not rub the flex material. Check the drive kit, which consists of belt sheaves and sheave bearings. Check for belt tension. On the solution AHUs, the actual data required by design for each fan assembly is listed on a tag affixed to the fan housing near the belts. Operating adjustable motor based. Secure the nut with a wrench placed through the service hole and loosen the bolt. Do this to all 4 hold-on bolts assembly. Make sure the drive bolt assembly threads are lightly lubricated. Turn both drive bolt assemblies in the same direction to move motor for belt installation and tensioning. Turn drive bolt assemblies independently to move motor for sheave alignment. Tighten all 4 hold-on bolt assemblies. checking the belt tension. It is normal for belts to loosen after startup or replacement. The new belt will run in or take a set by seating slightly deeper into the grooves of the sheath. Recheck tension after 1 day and again after 3 days. But I think those units up there are direct drives, so I don't remember them having any belts. The direct drives.
You can see any blue belts? No, right? No? No belt.
But just in case for the alignment, you place a straight edge against the outer edge of the sheath. Show the 4 points where the straight edge should touch the sheath, and straight edge should cross the sheaths at the widest part of the sheath. Or you can use a string. Tie the string around either shaft and pull it around the other outer edge for both sheaths to have a 4-point contact. To remove old belt and mounting hardware on the drive side of the motor, the drive side has 2 adjusting screws. Do not increase the left side more than ½ inch before increasing the right side. Remove the tension from the belt on the lower drive side using the adjusting screws. After the tension is removed from the belt, loosen the mounting hardware on the opposite drive side of the base. Continue to lower both ends of the base until the belt can be removed. It's a lot of belt stuff in here. Lubrication. Verify the type of bearing before lubricating them. A sealed bearing cannot be lubricated. Standard pillar block can be lubricated. You will see the lubrication port on the pillar block bearing. And whenever you introducing grease to these bearings, don't just keep pumping in there. You know, if you have tension on the tool that is pumping it in, then you know you can't go no more. Because once you break the seal, the bearing is now compromised. So a lot of people keep pumping it in until they see grease coming out, which is not the right way to go. If you see grease coming out, that means the seal is broken. And that bearing will have to now get greased more often than normal because the grease can't be trapped inside. If the fans will be down for 4 weeks or more, properly apply correct grease and rotate monthly to prevent moisture from damaging the bearings. Fan bearings on the AHUs are equipped with standard lubrication fittings. AHUs, which is air handling units, under 42 inches tall will have either extended lube lines enabling lubrication of both fan bearings from the side of the fan. For AHUs 42 inches tall and above, extended lube lines and external lube lines are optional. Some fans will have permanently lubricated bearings. Like those motors up there, I think they're permanently lubricated. There's no access to grease those motors. For specific fan bearing lubrication, check the instruction packet attached to the fan housing. Some forward curve fans are permanently lubricated. For best results, re-lubricate the standard pillow block bearing while in operation, if it's safe to do so. So for the pillow block bearings, they rather you lubricate it while the fan is in motion. So I wouldn't power it up, but I would spin as I lubricate. This way the grease gets to all the bearings evenly. Add grease slowly with the shaft rotating until a slight bead forms at the seal. If necessary, to lubricate while the bearing is stationary, then you gotta refer to the manufacturer data for maximum grease capacity for that size bearing. Re-lubrication is generally accomplished by a temporary rise in operating temperature. Excess grease will be purged at the seal. Wipe away purged grease after several hours of operation. Use a lithium petroleum-based grease conforming an NLGI grade 2 consistency. The lubricant must be free of any chemical impurities such as free acid or free alkali, dust, rust, metal particles, or abrasives. This light viscosity, low torque grease is rust inhibited and water resistant and has a temperature range of minus 30 degrees Fahrenheit to over 200 degrees Fahrenheit with intermittent high of over 250 degrees. Lubricate bearings as required by the severity of required duty. Keep motor bearings lubricated. Bearing grease will lose its lubricating ability over time because the lubricating ability depends primarily on the type of grease, size of the bearings, speed at which the bearing operates, and the severity of the operating conditions. Good results can be obtained if the following recommendations are used in this maintenance program. First one is to use high-grade ball or roller bearing grease such as Polyrex EM. For all T-frame motors. Maximum operating temperature for standard motors is 166 degrees. Be sure that the grease you are adding to the motor is compatible with the grease already in the motor. Consult the distributor or an authorized service center if grease other than the recommended type is to be used. Clean all grease fittings, remove the grease relief plug. If motor is stopped, add the recommended amount of grease. If the motor is to be greased while running, add a slightly greater quantity of grease slowly until the new grease appears at the shaft hole in the end plate or relief plug hole. Clean off any grease from the grease fitting. Run motor for 15 to 30 minutes with the relief plug removed to warm up the grease. Wipe off any grease that was pushed out of the relief plug. Reinstall the grease relief plug. Checking the electrical you gotta check the electrical terminations. You check conduit fittings and clamps for damage or looseness. Check operating amperage and compare the number to the number listed on the AHU nameplate. I don't see no UV lamps in those units, so. Filter types: flat angle, rigid, bag, HEPA, and charcoal are the typical filter types. If your AHU has HEPA filters, the filter frame, bulkheads, and segment panels are factory sealed and must remain sealed for no air bypass. Check filter sizes and quantities. Refer to the filter label located on each filter segment. Refer to the filter frame and cover. Remove old filters if present. Make sure gasket at both ends of the side load filter track are in place. The gaskets are normally found on inside of filter frame end covers. Slide the correct size new filters into track. On bag filters, leave banding in place while filters are installed. Then install the bag filters so that the pocket dividers are vertical if the filters are over 12 inches high. Airflow arrows must point downstream. Install all pleated filters with pleated position vertical. Reinstall the filter frame and end cover. Cleaning of dampers should be performed before operation is hindered in any way. Maintenance personnel must determine when cleaning is necessary based on observation and operation. Clean dehumidification coils annually, or when air pressure drop exceeds 125% of design. Cover electrical components such as fan motors, damper motors, compressors, which is not up there, thermostat, etc., with plastic. Care should be taken on interior coil cleaning. Remove filters, cover fan bearings, and any installation to keep those items free of water damage. Condensate drain piping should be screened to allow coil cleaning water to flow freely. Screening keep traps and drain lines from clogging and debris washed from the coils. Prior to any application of wet cleaning material, use a wide soft bristle paintbrush to dust off any heavy dust, leaves, bugs, or other foreign material that may be on the coil fin surface. Safety glasses should be worn when cleaning coils. When possible, remove dirt lodged in the depth of the coil by using clean, oil-free air under pressure. Caution should be taken not to use extreme high-pressure air, as this may cause the fin surface damage. Direct the air straight to the opening between the fins and never at an angle, which may bend the fins against one another. Always apply the air from the air leaving side of the coil. On heavy soil coils, use a safe commercial grade coil cleaner. Follow the safety and mixing instructions as noted on or with the cleaning agent. Spray the coil cleaning agent on both sides of the coil to be cleaned. Allow the cleaning agent to remain in contact with the dirt surface for about 5 minutes, or as recommended by the agent instructions. Then flush the coil with water from a hose with a spray nozzle or from pressure washer. Flush from the air leaving side of the coil. Caution should be taken as extreme water pressure may result in a fin surface damage. Direct the water straight to the openings between the fins and never at an angle, which may bend the fins against one another. This process will wash away surface dirt on the air entering side of the coil and prevent it from loading within the depth of the coil. You guys will be doing the coil cleaning of these, or? Most cleaners are concentrated detergent and can be diluted with up to 10 parts of water. Dilute as per cleaning agent instructions and coil conditions. Respray both sides of the coil with cleaner. Allow to stand 5 minutes and flush as described previously. Finish flushing from both sides of the coil. Follow the cleaning agent instructions. Agent should meet environmental and OSHA standards. Some extreme oil and dirt conditions may require steam cleaning. Most steam equipment can be adjusted to provide a mixture of water and steam at a moderate pressure. Cleaning the coil with steam should be done as described previously. Comb out any bent or flattened areas of the fin surface. Restore the equipment to its operational state. And now we're going to talk about the condensate drain, pan, and the trap, and line cleaning. Clean condensate drain pan, trap, drain line, and adjacent wetted surface at least annually, or as often as required to retard growth of microbial substances. Test drain pans to minimize conditions of water stagnation that may result in microbial growth. Field test drain pans under normal operating conditions to ensure proper drainage. And this is the exception. With the exception of field testing, drain pan is not required if units with factory installed drain pans have been certified by manufacturer or proper drainage when installed as recommended. To clean it, cover any nearby components such as motors, control devices, or wiring. Sweep, gather, and remove debris from drain pan, auxiliary pans, and splash guards. Scrape loose and remove any clinging substances. Cover drain pan outlet with screening to prevent drain clogging. Prepare cleaning agent per manufacturer instructions. Apply cleaning agent with spray applicator or brush. Apply cleaner to all surfaces, including underside of coil, header, and return bends if in airstream. Coil supports, coil wall or bulkheads, auxiliary drain pans, splash guards, any other surfaces subject to wetting by condensation, dripping, or carried by normal airflow. Drain pan and outlet. Add ample amount of cleaning agent to drain line and trap. Allow cleaner to stand for time required by manufacturer instructions. Flush with clean water from pressure washer or garden hose with spray nozzle. Apply as much water under pressure as possible to drain outlet to clean trap and drain line. Remove water from any puddle areas with wet vacuum. Wipe down if necessary to remove any stubborn material. Restore equipment to operational state. On the coil freeze protection, all chill water, hot water, and steam coils can be damaged during freezing weather. Take the following cautionary measures to prevent freezing. For year-round operation, glycol and other antifreeze solution must be circulated. During winter operations and shutdowns, such as power failure, night shutdowns, and weekend shutdowns, the controls must be installed so that the valves will go to the full heat position and all fresh air dampers go to the full closed position. The water circulation pumps must keep circulating water through the coils, or auxiliary heat must be maintained inside the air handler cabinet. Draining each coil and related piping such as traps and making sure that all low areas also drain. After draining, flush the coils with antifreeze solutions such as propylene glycol. Which we winterize in the drain. You gotta also winterize the drain pans. During the winter months, when the cooling system is turned off and the unit is exposed to freezing conditions, an antifreeze solution, which is environmentally friendly and safe for the roof, can be poured in the condensate drain trap to prevent freezing and possible damage. The condensate drain trap may also be removed as well as heat traced and insulated. Okay, so there's a lot of other information that the units up here doesn't have, so that would be it on those two units. If you guys have any questions, you feel free to ask. If you want to go back to the unit and look it over, feel free. All that information pretty much went for the heat recovery unit and the regular air handler, which is right by each other, and that goes for all the air handlers on site. There's only one heat recovery unit here anyway. So, thank you for coming. Enjoy your day.